Now the next solid structure which we are going to discuss in the topic of mensuration is a cylinder. A cube and a cuboid has its own respective shape and the dimensions. Similarly, let's see what is a cylinder, a solid structure of mensuration. Imagine I have this pen stand. In this pen stand, we identify that this is having a circle at the base and even circular at the top, but even the side is completely curved. So if this is completely curved, and imagine I want to cut this and then see what exactly this curved part would be when I strip it. See, as I see this is called a cylinder. So let's see each of how we can identify the lateral surface area or the curved surface area and the total surface area and the volume. So before we understand the cylinder, let me just draw the diagram of cylinder here, where I have, say for example, this is how I draw, where this is the top surface and this is the bottom surface. Is how I get the cylinder. Now let me say the radius of this cylinder, when I have the circular region, the radius of this cylinder is, say, it's R. This is the radius. And let me say the height of the cylinder is H. Now based on the dimensions of the radius and the height of the cylinder, let's see how we can find the complete areas of the lateral surface area or the total surface area of the cylinder. Now, when I have the upper region which is a circle and the lower region which is a circle, then I have area of this circle is pi r squared is what we get. So initially let me start with each of the cylinder, where this is a circle So when I divide the region, initially the upper part comes out as a circle and this curved surface comes in the middle, and down part, which is a circle, comes down. This is how we understand the cylinder with three basic structures. One is the circle, one is the curved part, and one is also the other circle. Exactly these two circles are equal. So area of this circle is no doubt pi r squared, which we all know. And area of this circle also being equal to that is also pi r squared. Now the question comes on how I find the area of this. Now as I said, this clearly is curved, and hence this is called curved surface area. This is flat, so flat, flat or flat. Instead it is open here, and this here it is curved. So I need to find the curved surface area of the curved part. How do I find this is the biggest question out here. So in case of this, imagine I cut the cylinder at one region and then I pull it up, then I see that this curved part becomes a rectangular strip. As you can visualize this, I identify that when I cut this and expand, this becomes a complete rectangular strip, which again on rolling becomes a curved cylinder, the curved part of the cylinder. So the area of this curved part is nothing but the area of this rectangular strip. So let's see how the area of this rectangular strip can be found using the geometrical dimensions. Now coming to this, I clearly see that this is nothing but 2 pi r. Why is this 2 pi r? Because this acts as the circumference of the circle. As I see that this strip is totally out here in this form. So when I pull this, I totally get the circumference of the circle becoming the length of the rectangle. the whole of the strip circumference becomes the length of the rectangle. So this being circumference of circle is nothing but length of rectangle. And obviously my height, which is the width of the rectangle, is h. Therefore, my total surface area is area of the upper region, area of the lower region, and area of the rectangle, which we clearly know that the area of this rectangle is 2 pi r into h, because length into width is this into this, which comes as this. Therefore, if I wanted to find curved surface area, I take only the curved part, which is nothing but the rectangle. As I can see that the curved part, when pulled straight on the flat surface, I get a rectangular strip with these dimensions. Therefore, curved surface area would be 2 pi r into h. Is how I understand the curved surface area of a cylinder. Next comes on what is the total surface area of a cylinder. As I see that the total surface is the curved surface plus the top and the bottom surface. When I split this, this plus this plus this is nothing but the TSA of a cylinder. This being pi r square, and area of this being area of this, which is 2 pi r h. And here, the area of this being pi r square gives me, when I simplify this, I get 2 pi r times r plus TSA of a cylinder, and curved surface area of a cylinder is given by this, and the cylinder, which stands for its curved surface area and the top and the bottom. Now, interestingly, in this question, sometimes as I see this particular object, I see that this is an open cylinder. Sometimes we have the closed ends, which are closed cylinders. Now, the question is, if I wanted to find the surface area of an open cylinder, for example, this case, then I don't have the open surface, but I have the bottom surface. So in this case, my surface area or the total surface area would be CSA plus 1 of the circle, but I don't include this circle because there's no area, it is hollow inside. So in this case of this cylinder, let me see what the area is for one side open. So in case of a one-sided open cylinder, let's see what is the total surface area covering the complete curved surface and the top and the bottom. Now, as I see that this is a one-sided open cylinder, I see one of its side is open. That means I don't include the circle on the top, but I include the circular region on the bottom. Therefore, the upper part of is not included. Only the middle of the curved surface and the bottom circle is included. So that when I wanted to find, we already know that the curved surface here is 2 pi RH, which is already found in the previous session. And area of this circle is pi r square. Therefore, my TSA of an open cylinder is 2 pi RH plus pi r square is what we get. Or to simplify this further, pi r into 2h plus r is the total surface area of a one-sided open cylinder. So now with this, we can imagine on how the two-sided open cylinder will have the TSA. So note, the total surface area of a two-side open cylinder would be, can you guess? A two-sided open cylinder does not have even this circle into existence, so it is nothing but the CSA. It is nothing but CSA, and that is 2 pi RH. So TSA of a two-side open cylinder is nothing but the curved surface area, only the curved part included, and that is 2 pi RH unit square. Is how we understand the surface areas connected through the geometrical dimensions of radius and height of a cylinder. Now next comes on how do I find the volume of the cylinder? How do I know how much space does the cylinder occupy inside the region? So how do we find the volume is the biggest question next. Now here the next question is about the volume. As we know that volume of a solid structure is area of base into height. So let's use that general property of a volume to see what exactly is the volume of the cylinder. So as I find that volume is area of base into height, therefore volume of cylinder is nothing but area of base, which is a circle, and hence area of the circle is pi r square, times the height of the cylinder is h, therefore it is pi r square times h. That implies volume of a cylinder is given by pi r square h unit cube. Units are very important in solving the problems. Getting the answer and putting the units in mensuration has to be taken proper care with. Now this is how we get the volume of the cylinder, which is pi r square h unit cube. Now let's see the next solid structure, which is called a cone. Now we all know the cone. We are quite familiar because we eat ice cream inside a cone. Now let's see how that cone is constructed for the areas. A cone is generally in the shape of a sharp object at one end and then circular at the bottom. So this is the shape of a cone. A birthday cap is also the shape of a cone. So when I take this cone, in this, if I take a larger object off, then clearly I get this to be a solid cone, which I get. And here the radius of the cone is r and the height of the cone is h. Is how we have the dimensions. The radius is r and the height is h, and this is called a right circular cone because here the radius is always perpendicular to height. So a cone is also called a right circular cone because this is 90. It is called right circular cone with radius r and height h. Now as I consider this in the similar manner as I have considered the cylinder, let me see what are the different faces it has for finding the curved surface area or the total surface area. As I see that the base is a circle and the upper part is a curved surface, therefore I understand that this is having two of the regions. One is the curved part on the top and the other is a circle in the bottom. Repeat. Now in this case, I take a cone with radius height r and height h, and also I consider the slant height, which is L. So in this case, we have to remember r is the radius of the cone, h is the height of the cone, and L is its slant height, which helps us in finding the curved surface area. The slant height is the height which is considered slantily on the side. It is the hypotenuse of the right angle triangle. Say I take this as OAB. If this is a right angle triangle OAB inside, then the distance AB will be the slant height, which is the hypotenuse of right angle triangle. Now, as I see this three-dimensional cone, let's see how the curved surface area or the curved part of the area can be formed. Now here, let me take the curved surface part of the cone and see how this becomes in the shape, in its two-dimensional shape when it is put on a flat sheet. So imagine I remove the curved part of the cone and I just stretch it to lay down on the ground and see what exactly the shape is. Before doing that, I would like to have a small activity with the paper. Now let me take an A4 size paper which is in the rectangular shape. Imagine this is the length and this is the width of the rectangular sheet. Now as I can make a cone with this, if I just roll this in the form, I can form a cone, as many of the shop vendors try to do this by putting something in and giving us. This is the curved surface of a cone. Now how did I obtain the curved surface of this cone? If I just put it here and I put the triangle, the circle down in the base, this forms a cone, the top surface or the curved surface. So indirectly we assume that when a rectangular sheet of paper is rolled, I can form the curved surface area of a cone. Therefore, to get the curved surface of a cone, I stretch it. When I stretch the curved surface, I get a rectangle. So let's see how the dimensions of the rectangle would be. This is the rectangle I get when I stretch the cone. Now this is the length and the width. So using the dimensions of this, as I see that the base is a circle, exactly when I stretch, I get the base of the circle plays a role in identifying the dimensions. As I clearly see that the width is L because the slant height is given to be L of the sheet of the curved surface part. So this L acts as the width when I stretch it on the ground flat. And here, as I see that when I stretch, I get half of the circumference which gets stretched on when I put on the ground. The half of the circumference which is on the base becomes pi r, because for the semicircle the circumference is pi r, that is pi r into L. So in this case, if I wanted to find area of the curved surface part, is nothing but finding the area of the rectangular sheet. So in this, my CSA is nothing but area of rectangle which I have obtained here, which is nothing but pi r into L, that is pi r L. So my curved surface area is pi r L is what we get. Similarly, if I wanted to find the total surface area, is nothing but pi r L plus the area of the circle which is missing here, that is pi r square, the base which is a circle, which on simplification gives pi r into r plus L. Therefore, the TSA of a cone is pi r into r plus L is what is obtained. So the curved surface, TSA, and are the different dimensions, are the different areas which are existing in the cone. Similarly, the volume. Now what is the volume of cone? Now the volume of a cone is given as 1 by 3 pi r square h. This is the formula for volume of a cone, which is obtained from a cylinder. Usually I have, if I construct a cylinder, I can construct a cylinder from a cone in this way. So this is, cone is a part of a cylinder which is 1/3, because 1, 2, 3. There are 3 cones which are combined to form one cylinder. Therefore, volume of a cone is 1/3 of volume of a cylinder. This is how I get this 1/3 of volume of cylinder, which is pi r square h, and hence volume of a cone is 1 by 3 pi r square h. Is how we understand the properties of the cone. The next is the sphere. Now in sphere, let's see what is the difference between a curved surface or a total surface. As we know that every angle of the sphere is a surface which is curved. Therefore, the whole of total surface area is nothing but the curved surface area. As I see this is a sphere or a globe or a football or a cricket ball. So this sphere, if suppose my internal radius is r, the distance from center to one of the corner of the sphere is r, then here the curved surface area of a sphere is nothing but the total surface area of a sphere. So both the curved surface and total surface are equal, and that is equal to 4 pi r square is what we get as the formula. The proof of which is beyond the syllabus, where the curved surface or this is this. Now because the curved surface and total surface are equal in a sphere, we simply call this as surface area of sphere is 4 pi r square unit square is how we understand the surface area. Now next comes on the volume. The volume of the sphere is given by four by 3 pi r cube, where r is the radius of the sphere, which is from the center to one of its corner on the sphere, on the surface. So surface area and the volume of sphere using the respective form. Hemisphere. Now what happens if I cut the sphere exactly in the middle? So what happens when I cut the sphere and exactly, say for example, when I take a sphere and just cut it exactly in the middle with its radius r, then I get two regions. So these are the two regions which I obtain when I cut the sphere in the upper region and the lower region, cutting exactly on its radius. It's exactly on the radius. On the diameter, taking it through the diameter, I get two regions which are hemispheres which I get. Now in this, I see that the radius is r, and then we have two regions here. One is the curved surface. This is the curved surface, and this is the region. There are two regions here. One is this region is a circle, and this region is curved surface. So using these two regions, I'm going to find the area or the total surface area or the curved surface of the hemisphere. Therefore, CSA of hemisphere will be exactly half of the surface area of sphere, because exactly it is cut in the middle. This part is half of this. Therefore, half of the surface area of sphere, which we have already found to be 4 pi r square, 4 pi r square, which on simplification gives 2 pi r square. So curved surface area of a hemisphere is 2 pi r square. Now, when I want to find TSA of hemisphere, this is CSA plus the circle which is on the top. So I get two regions. One is the circle and one is the hemisphere curved surface, which on simplification gives 2 pi r square plus area of circle we all know is pi r square. Therefore, this on adding gives me 3 pi r square is the total surface area, and 2 pi r square is the curved surface area of hemisphere. Similarly, when I take the volume, then volume of hemisphere is exactly as I see, because this object is half of the entire object, when I cut the total ball exactly in the middle, I get half the ball, and half the ball is half the volume of the original volume. Therefore, volume of hemisphere is simply half the volume of sphere. But the volume of sphere is already identified to be 4 by 3 pi r cube, which on simplification gives 2 by 3 pi r cube, which is the volume of hemisphere. The curved surface area, the total surface area, and the volume of the hemisphere is how we understand the concept. But the most important point we need to note here, because some of the questions are very challenging, is that since the radius is r, the depth of the ball is also r. So imagining this depth of the ball also to be r is very useful in visualization when we do many complex problems. So depth of the ball is radius of the ball. The hemispherical ball is how we understand through the geometrical structure. Prism is the next solid structure which we are going to consider in the mensuration. Now, what is a prism? Usually, a surface which has two triangular regions and rectangles out there is a prism. Say, for example, I have this, which is a triangle out here and a triangle out here, and then I have rectangles 3. So, as I identified, there are two triangles and 1 and 2. And there are 3 rectangles, 1, 2, and 3. So 3 rectangles and 2 triangles make the prism, which is somewhat in the shape of like this, the triangle out there and each of the region. So when I put this prism exactly on the ground like this, on the flat surface, then I get a kind of a shape which is like this. Now here I wanted to find the lateral surface area, because this region doesn't have any curved part, it is everywhere flat, so we cannot have the curved surface area, but we can have the lateral surface area. Now when I put this prism out there flat on the ground, then the lateral surface area is the area considered along the horizontal axis. Therefore, this is the area which I get as the area of the prism. Therefore, my lateral surface area is, when I add the 3 rectangles, I get the lateral surface area of prism. In this case, the formula being the LSA of a prism is perimeter of base into height. So this is the basic formula we generally use in simplifying that for the lateral surface area without its dimensions. So when I have the lateral surface area, it is perimeter of base into height, and the total surface area is the lateral surface area plus the area of the 2 end surfaces, that is N1 and N2. So therefore, with these 2 ends, N1 and N2, I have the total surface area, which is lateral surface area plus twice area of the end surface. Now here I take twice because area of this end and area of this end are equal. Therefore, when I add, I get twice of one of the area of the end surface, which on the whole gives me total surface area is the lateral surface area plus area of this plus area of this. Totally makes the TSA of a prism. LSA plus twice area of the end surface. Next comes the volume. So if I wanted to find the volume of the prism, then we use the basic formula. Volume of prism is area of base into height, is the formula which we generally use in finding the volume of prism, which is area of the base, which is a triangle, and the height, which is the length of one of the rectangle. So area of the base, which is calculated with the respective dimensions, and the height multiplied gives me the volume of prism. the prism which is in this shape. Now let's see the next solid structure called the pyramid. Pyramid is quite familiar in historical facts because we see many Egyptian pyramids. What is a pyramid? A pyramid is also a conical shaped structure which has each of the surface to be flat. There's no curved surface out there. For example, when I take this, it has 4 triangles in its lateral part and 1 rectangle or a square on its base. So for the base being a rectangle and each of the lateral faces being triangles is what makes the pyramid, the shape as out here, the Egyptian pyramids. So in this case, we are going to exclusively study about right pyramids because right pyramids are the one which help us in deriving the formulae for the right pyramids. So what is a right pyramid? A right pyramid is a pyramid where when I join the vertex to the base, I need to have this perpendicular. So this perpendicularity is what makes the right pyramid. So the height of the pyramid, if it is perpendicular to the base, then we call this as a right pyramid. If the height is not 90 degrees with the base of the pyramid, then that cannot be a right pyramid. So in this right pyramid, we have the lateral surface area, which is given by half the perimeter of base into slant height. This is the formula which is exclusively used to find the lateral surface area of the pyramid is given by half the perimeter of the base, which is a rectangle, into the slant height. The slant height is this height. This is the slant height, which you are going to calculate through the dimensions as given. All the slant heights are equal. Therefore, the slanted height is what we consider here. Similarly, the TSA is nothing but the lateral surface area which is taken horizontally plus the base, area of the base, which is a rectangle here. Is how we derive the formula for the pyramid. The TSA is LSA plus area of base. Next comes volume. So what is the volume of a pyramid? How do I find the volume? The volume of pyramid is given by 1/3 of area of base into height. So this is the volume of pyramid, which is 1/3 or area of base into height of the pyramid, which gives me the volume of pyramid. The lateral surface area, the total surface area, and the volume of the pyramid, the right pyramid, is we get through the formula.